time we started the curvilinear motion using tangent normal coordinate system, which is a chapter. Velocity and acceleration equations, but at the end of the day, I told you I'm not going to ask you about the proof, and there's an equation sheet here that is going to have all the equations that you need. So basically, if you compare the equation sheet, you are going to find the Cartesian coordinate system, r, v, and acceleration. And the tangent normal, you are going to find the velocity and the acceleration. Cylindrical coordinate system, you are going to find the equation of the velocity and acceleration. So all the equations are already in the equation sheet, but you have to know what is every component in each equation and how to plug in numbers in this equation. And you will not be able to know that until you understand where these equations came from. So our equation for the velocity v was equal to, which is always in the tangent direction, always in the ut hat. However, the acceleration has two components, a tangent, one of them in the ut hat direction, and one of them it's in the normal direction, un hat. So if you have, for example, a curve like this, so if you have this point is moving, always the velocity is tangent in the tangent direction. So the magnitude of v, and also it's in the direction of the ut hat direction. And this is the normal direction, so if this is t hat and this is n hat, so let's say, for example, the acceleration as a vector, the total acceleration is that way, is going to have two components. One of them is in the t hat direction, however, it can have positive sign or negative sign based on this body, is accelerating or decelerating. So this is the a tangent, and you're going to have another component here, it is the a normal. And we proved last time, what is these values? So you are going to have, this is equal to rho, the radius of the curvature, multiplied by the angular velocity, theta dot, in the ut hat direction. And the acceleration, the at, is actually related to the velocity. So it's the time rate of change of the velocity magnitude. So the at component, let me write it here. This is the time rate of the change of the velocity magnitude. And this component is the time rate change of the velocity direction. So, and at the end of the day, the acceleration is going to be equal to rho theta double dot in the ut hat direction, and we proved last time that the normal acceleration is equal to v squared over rho, and this is in the un hat direction. So that's what we did last time. The most two important equations is this one and this one. That's what I need from here. Okay, so let's solve an example, which is a direct application. All right, this one. Example 1214. this example, say when the skier, this is how it starts, says when the skier reaches a point A, so this is a skier reaches a point A and is skiing downhill along a parabolic path, and this path lies here. If I want to see this path has an equation y equal to 1 over 20 x squared. That is the equation of the path that the ski is moving on. He has a speed of 6 meters per second. So the skier's speed at this point, the speed v, let's say, and it's always tangent, this is VA. So VA of the skier is equal to 6 meters per second. And watch out for this, which is increasing at 2 meters per second squared. This speed, when I say that the speed is increasing, like the magnitude is increasing by 2 meters per second squared. So what is this 2 meters per second squared?
Acceleration.
What kind of acceleration? I have two. I have tangent, I have normal. Tangent, because I'm talking about the speed as a magnitude is increasing. Okay, but if I said the total magnitude of the acceleration is increasing, so that means that A as a total magnitude, which is the A tangent squared plus the A normal squared. But if I told you, and watch out for this, if I told you that the speed is increasing by this, that means I'm looking how this speed is changing. So the magnitude, not the direction. Okay, so A tangent is positive 2 meters per second squared. So that is given. And I'm asking you, determine the direction, determine the direction of his velocity. So I want to know, number one, what is the direction of the velocity? So basically I want to know, I give you the velocity, and I want to know what is the direction of the velocity. Definitely it's going down. And the direction and the magnitude of the acceleration. Let's say I want, this is the acceleration, I want the magnitude, and also I want the direction. So when I say the direction and the magnitude of the acceleration, that means it is the total acceleration. When I say just acceleration, that means total. If I talked about how the velocity is changing over time, so I'm talking about tangent acceleration, okay? For normal acceleration, I would say you directly, the normal acceleration is equal to this, right? Okay, so since I give you the curve equation, and we know that the velocity is always tangent to the curve. So basically, if you want to know the direction of the velocity, you have to do something with this curve. What I'm supposed to do? So since it's exactly, excellent. So I want to find the slope because the tangent of this curve, that means it's the slope of this curve. So I want to find this angle. So to find this angle, you need to find dy dx, right? What is dy dx of the curve? The curve is y equal to 1 over 20 x squared. Can you guys tell me what is dy dx?
1/10 x.
1 over 10 times x, right? I give you in this problem that point A, it's already given that this distance is equal to 10 meters at point A, and the height is 5 meters. That's all given. So if you want to find the dy dx, which is the slope of this curve at this point at x equal to 10 meters, so basically you are going to substitute here 1 over 10 multiplied by 10 is equal to 1. So what is this angle? If dy dx is equal to 1, it's 45 degrees, right? So basically dy dx is equal to the tan inverse of theta of the angle is equal to 1. So theta, tan theta is equal to 1. So that means theta is equal to tan inverse of 1. If you put it on your calculator, it's going to give you 45 degrees. So the angle theta is 45 degrees. So that is the first thing. So theta is equal to 45 degrees. So did I did any dynamics here? No, it's all basic math. All right? You know that the slope of any curve is the inverse derivative of the curve. So that's what I did, and I substitute by the x coordinate here to get the angle theta.
All right, how about the acceleration? Acceleration is a little bit complicated. Velocity was easy because I know that the velocity is always going to be in the tangent direction, doesn't have any normal components. So for the acceleration, I have to do more steps. So I know that the acceleration is going to have component in the tangent, which is already given, a tangent. Why assume a tangent in this direction? Because I said early in the problem here that the velocity, the speed of 6 meters, which is increasing, so that means it's going down. If I said it's decreasing, so that means that the a tangent is going in an opposite direction of the velocity. So I know that this is going down. How about the a normal? Can you guys tell me where's the normal acceleration is going? Is it going to be this or down? It's always going to the center of the curve. So it's going to be something this way. All right, that's the normal acceleration. So to find the normal acceleration, I know that as a magnitude, the normal acceleration is equal to v squared over rho. So an is going to be equal to v squared over rho. I know v, it's already given 6 meters per second. How about rho? Rho has a rule that is, I believe it's also given in the sheet, but if it's not, you should put it in the sheet. So if you know the equation of a curve, the radius at any point on this curve is equal to a very long rule. It is a very long equation, 1 plus dy dx all squared, and all this is to the power 3 over 2, and this is divided by d squared y dx squared. That is a general rule. The radius of any point on this curve is equal to this rule. And why the radius is changing? Because this curve is keep getting changed. So at each point, it might have completely different center. And the radius is going to be different. So if I want to find the radius of the curve at this point, I have to find dy dx, which I already found. Dy dx is equal to 1 over 10 x. And if I want to find this, and x is equal to 10, so this is going to be equal to 1. I already got that. The second thing, I want to find the second derivative. Can you guys find the second derivative? The first derivative was 1 over 10x. So if you differentiate one more time, 1 over 10, which is constant. All right, so I found the two variables to substitute in this equation. So the radius of this curve at x equal to 10 is going to be equal to 1 plus dy dx, which is another 1, squared is going to be still 1, to the power 3 over 2. And here I'm going to have 1 over 10. So once you substitute in this, the radius is going to be 28.28 meters. So I got the radius of the curve. Right now I can get the magnitude of the normal acceleration. I have the velocity given already 6 meters per second, so 6 squared over 28.28, and this is gonna give me, I solve this problem in a different way, but the answer is gonna be 1.27 meters per second squared. So right now I have a tangent and I have a normal, and I know that the magnitude of the acceleration, like if you know this and this is gonna be somewhere, which one is bigger, a tangent or a normal? This is 2 and this is 1.27, so it's kind of very close to the a tangent, somewhere here. So this is the total a, so it is gonna be the square root of a tangent squared plus a normal squared, and this is gonna be 2 squared plus 1.27 squared. So this is going to be equal to 2.37 meter per second squared. Next step, I found the magnitude of the acceleration. I want to find the direction of the acceleration. It's very easy. If you want to know the direction, you have to find what the angle that you have here. And to do this, like let's say, for example, I have a tangent equal to 2, and a normal is equal to 1.27. If you want to find where is a, so you have to find this angle. we called one theta here. So let's call this different because let's call this phi. Let's find phi. Can you guys find phi? Phi is kind of like tan phi is equal to the opposite over the adjacent. So the opposite is 1.27 divided by 2. So basically, if you want to find phi, it's going to be equal to the tan inverse of 1.27 over 2. And this is going to give you 32.41 degree. By the way, you can say 1.2, like you can say 2 over 1.27, but you are going to get this angle. So whatever you would like. So right now, I know the angle between the tangent and the acceleration. I know this angle. This angle is, what is it? 32.41. All right, so if you want to find the angle between this and this, basically it's a 45 degree minus phi, because I know that this is 45 degrees. So if you want to find this angle, let's call it xc. xc is going to be equal to 45 degree minus 32.41, and this is going to give you 12.58 degree. So usually, if I want to put this acceleration, this is my horizontal, and the acceleration is somewhere here, and the velocity is somewhere here. The velocity is equal to 2 meters per second, and it's an angle 45 degree. And the acceleration as a total is an angle 12.58 degree. Did you guys get that? Does anybody have any question?
You explain where you saw for P, so you have dy dx, like, you have 1 plus 1, 3, so dy dx equals 1, right? Dy dx is 1.
Dy dx is equal to 1 because x is equal to 10.
So then why, what I'm confused about is why you have, like up top, you have dy dx, 1 plus dy dx. And then you have
1 plus dy dx all squared.
Yeah, which is still 1. But
Yeah.
then you have it all over dy dx squared.
Yes.
And so why is the dy dx squared 1 over 10?
Because the thing is, if you differentiate this one more time, the main equation is 1 over 20x squared. You differentiate it once, it's going to be 1 over 10x. You differentiate it one more time, it's going to be 1 over 10. You differentiate it one more time, it's going to be 0. Right? So this is the basic differentiation of the variables. Alright, so this is how you get the directions. That's why I shouldn't have left it when I got phi, because when you got phi, it's the angle between the angle that the acceleration have with the tangent. What we look for is the acceleration angle between the horizontal. So that's why I subtracted 45 from the phi. Alright, so
Excuse me for asking a question. What are we calling theta then?
what we call what?
Theta.
Theta?
Yeah.
So theta was the reversed angle, right? Theta is the angle that the velocity has with the horizontal.
Okay.
So, yeah.
Thank you.
Okay, so let's solve another problem. Gonna do it here. All right, this is example 12.5. This is a circular race track, like a track that the cars would drive in. I put it as an oval so that you can imagine how it looks like. And you have a car somewhere here. You have a car somewhere here, and this race car C travels around the horizontal circular track that has radius of 300 foot. So you have the radius here, 300 foot. I give you the radius. Once I give you the radius, your brain always go to this equation, because radius is only matters for the normal acceleration. So once radius is given in the problem, think about the normal acceleration and just put this rule. AN is equal to d squared over rho. So somehow if I give you the radius, you either, there's a way to get the normal acceleration so that you can get the velocity, or there's a way that you have already the velocity given to get the normal acceleration, okay? All right, so I already gave you the radius. The radius is equal to 300 foot. Okay, what else? If the car increases its speed, all right, increasing the speed, so what does that mean? Increasing the speed, that means acceleration, and this is gonna take my frame to the tangent acceleration, because this is the only, like the tangent acceleration is the time rate of a change of the velocity magnitude. So increasing the speed, that means increasing the magnitude of the velocity. So I'm saying that the tangent acceleration, A tangent, is equal to 7 feet per second square. Why? Because I said that if the car increases its speed at a constant rate, so this is a constant rate equal to 7 feet per second square. It's starting from rest, so we know that all this starts from the rest. Determine the time needed for it to reach an acceleration of 8 feet per second square. So determine the time t. I want to find what is the time t. But under one condition. What is this condition? To reach an acceleration. By the way, I said acceleration, general term. I didn't mention is it tangent or is it normal. To reach an acceleration of 8 feet per second square, that means that your total acceleration is going to be equal to 8 feet per second square. So I give you a tangent, I give you the total acceleration. First thing that is going to happen, I'm going to think about, oh, I have A and I have A tangent. That's very easy to get AN because I know that A is equal to A tangent squared plus A normal squared. Or I can remove this square root and put a square here, right? So this is given equal to 8, and tangent is equal to 7, plus A normal that I don't know is equal to AN squared. And that's what I told you in a little bit, that A normal is equal to V squared over rho. And I give you rho, and I give you some information to find the normal acceleration. So this is gonna give me what is the velocity is. So basically, once you solve this, you are gonna find that the normal acceleration is equal to, let's see, can you guys do this? Because I'm solving it in a different way. Try to find this value, very quick. 8 squared minus 7 squared.
33.87.
Did you take the square root? 3 point what? 87 meter per second squared. All right, I got A normal. So basically I can say that AN is equal to V squared over rho. I have N and I have rho, so I can say that V squared is equal to 3.87 multiplied by the radius 300, and then I can get V. Can you guys get V? Okay, V is equal to 33.9.98.
Where'd you get AN? Where'd you get AN from?
AN, because I already give you the tangent acceleration, and I give you the total acceleration. So A is equal to, A squared is equal to A tangent squared plus A normal squared, right? Here, you see? I have AN and A tangent. A is equal to A tangent, A squared is equal to A tangent squared plus A normal squared. This is given, this is given. I easily can find A N. All right, so I found the velocity, and this is meter, sorry, this is feet per second. All right, I got the velocity. By the way, I'm asking here in this problem, determine the time needed for it to reach acceleration of 8, and what is the speed at this instant. This is the speed at this instant. All right, so I got the speed. Let's find the time. Right now, you have tangent acceleration and you have velocity. By the way, if you have velocity and you have acceleration, you can get time, because you know that the acceleration is the time for the change of the velocity. Because if you remember, A is equal to dv dt. And in the past, we said that A dt is going to be equal to dv, and you can integrate both sides. And also, this equation is always applicable on the tangent velocity, because the tangent velocity is the time rate of a change of the acceleration magnitude. That has nothing to do with the normal acceleration. Normal acceleration always just to keep the particle in track. So here, you can basically say that V minus V naught equal to the integration of A dt. So V, it's already given. Oh, sorry, we just calculated 33.9 33.98. V naught is 0 because the body started from rest. The integration of A dt is constant because that's a constant acceleration. I already give it to you in the problem. So it's a 7, so I can take 7 out of the integration of dt from t naught to t. So this is 0. So this is going to give you 7t. So basically, the velocity is going to be equal to 7t. And that makes sense if you have everything is constant. A is going to be equal to v over t. So A is equal to 7. The velocity is 33.98 over t. So 33.98 is equal to 7t. All right, so right now I can find out that t is equal to 33.98 over 7. And this is going to give me time equal to 4.87 seconds. The way that I solved it here, I tried with this first. And then I got the velocity, I got this equation, that the A acceleration is equal to 7t, and then everything was variable in t, but this is much easier. I get the velocity, and once I know that the velocity is, I can substitute here, so all the equation is just one variable, one equation, and it's much easier.
So basically, if we already have V and A, because A was given, so we found V, I can just use A equals V over T.
Yeah, you can do this, but this is only valid if the A is constant. If A is variable, so you cannot take it outside of the integration, and you have to integrate the function of A with time. So,
Okay.
all right.
Does it usually say in the problem when it's
Absolutely, like here in the problem, I say that the speed is increasing with the constant acceleration if its speed is at a constant rate of 7 feet per second squared.
okay? Thank you.
Sure. So, let's solve another quick one. So this is unsolved problem is also in the textbook. It's 1214. So this problem, it says that you have a curve and a car is moving on this curve. And I give you the automobile has a speed of 80 feet per second. So I give you that this V has 80 feet per second at point A, and an acceleration having a magnitude of 10 feet per second. By the way, I said acceleration, it's a very general term. So I didn't say that this speed is increasing with a specific rate. I'm just saying that the acceleration, I don't have to say total acceleration. So once I say general, that means A is equal to 10 feet per second squared. And I told you that this acceleration, by the way, this body is moving that way. So this is the tangent and this is the normal. And the acceleration is an angle of 30 degrees. I give you this as well. So acting in the direction shown. So the 10 feet is acting in this direction, the 30 degrees. So you have to read the figure and see how is the angle of the acceleration. All right, determine the radius of the curvature. So determine the radius of the curvature of the path at point A and the tangential component of the acceleration and A tangent. So let's find out. Okay, first I have A and I have the angle. So I know that I have A tangent that way and A normal is it that way. So basically, can you guys tell me what is the value of A tangent? Just I'm gonna get the components of A in the tangent and the components of A in the normal direction. So A tangent is equal to A cosine or sine?
A tangent would be cosine, no?
Cosine 30. How about the A normal? It's gonna be A sine 30. So this is gonna be 10 sine 30, 10 sine 30, and this is gonna be equal to 8.66. And this is equal to 5 feet per second squared. All right, can you guys tell me what is the next step? By the way, you have, I'm asking for rho, you have V, and you have an A normal.
So we can use the formula that is A normal equals to V squared over rho.
Excellent, so I have AN, I just got it, 5, and I have V squared, it's already given, 80 squared, and I have the radius rho is unknown. So basically, rho is gonna be equal to 80 squared over 5, and this is gonna be equal to 128 foot. So I already got this one. So we found everything. We found the tangential component of the acceleration, AT, and we found the radius. Very easy problem. Does anybody have any questions so far? I solved it. Another extra one you will find here, problem 1216. And we're gonna find the solution here as well if you want more practice.
Question, Professor.
Yeah.
So the A tangent is always in the same direction as the velocity, right?
It is in the tangent direction if the time rate of the change of the velocity is increasing, like if the acceleration, if the car is accelerating, it is gonna be shooting that way with the velocity. But if it's decreasing, it's gonna be in the other way of the velocity. So it just depends. So it's either positive t or negative t. If it's in the same direction of the velocity, that means it's positive. If they are opposite direction, that means it is negative. Okay? Here, I just told you that A is in this direction. So you know that A is in the tangent. It's already given on the curve. All right, so we are done right now with the normal tangent direction. So let's find out how we can solve problems in a different system, like in a different coordinate system. So right now we are gonna start chapter 12.8. It's curvilinear motion using polar or cylindrical coordinate system. R and theta. It's called, you can call it polar or cylindrical. All right, let's see. So this is my XY coordinates. So I have X and I have Y, and my body is here. If my body is moving on a circular plane, which is usually if you have an arm and this arm is been at one end and this arm is keep moving that way, it's much easier to do R theta coordinate system. And R theta basically, from the origin, you straight a line to the particle or to the body, this is called R, the position of the body. And this is the R hat direction. And theta is a perpendicular to R in the direction, in the increasing direction of theta. Like if theta is this body is going up, so theta is going that way. If the body is moving down, so theta is moving down. So if your arm is moving that way, theta needs to be that way. If the arm is moving down, so it has to be in the other direction. So this is the direction VR, the direction of R and theta. The thing is, the same concept, velocity is gonna be always tangent to the curve. Like the velocity is gonna be always, doesn't matter what coordinate system you are using, tangent, normal, Cartesian, R and theta, that your velocity is gonna be always your velocity is gonna be always that way. V is always tangent. It helps in the tangent normal that all the velocity components are in the tangent direction. But here, since you have R and theta, so you are gonna have to analyze this V to give a component in the VR direction and a component in the V theta direction, right? Before here, the velocity is always in the tangent direction. So usually when we write the velocity, like if I want to write this velocity vector in a tangent normal, v is equal to all the v80 in the tangent direction plus 0 component in the n-hat direction. However, if you want to put it in xy, there's going to be component in x, component in y. If you want to put it in r and theta, there's going to be component in r and component in theta direction. So this is the only difference that we have for now. Okay, so let's do the same thing that we did with every coordinate system. We try to track the position, the velocity, and the acceleration. So let's take them one by one. The position, r. The position of your body, it is always like if you want to find the position of your body, it's an xy position. So you are going to have a component in x here and a component in y. But the position of your body is at that distance in the r hat direction. So basically, the position is r in the ur on the r hat direction plus 0 component in the theta hat direction. Because your body is at a distance r here. There is no component in the theta direction. However, the velocity has two components. You are going to end up with having vr in the r hat plus v theta in the theta hat direction. These two components. All right? Okay. How about the acceleration? Let's talk about acceleration first, but let's focus on this. How we can find the value of VR and V theta? Does anybody have any questions first about why all the position is in the R direction? Yeah.
Why do you put a 0?
Why did I put a 0? Let's say I have X and Y, and my body's here, and I want to describe the position of this body, and this distance is 5, and I want to say what is the position of my body. So it's going to be 5 in the X hat direction plus 0 in the Y hat direction, right? Because all the distance is in the X hat, right? So what if I rename this? Rather than X, I'm going to name this R and this theta. So basically, all the 5 is in the R hat direction, right? Here. And 0 in the theta hat direction. This is the same thing. Let's take this and put it horizontal. Rotate. All this distance is in the R hat direction, and there is no distance in the theta hat direction. That is the best thing about this system, that makes it 0 in the position. But in the T hat, no. In the X, no. But this, the best thing about this system, it puts 0 in the n hat direction. So every system has its pros and cons. Some of them, they are gonna make 0 in the end. Some of them, they are gonna have the zeros in the position, all right? Okay, so let's find the velocity. Velocity, if you wanna find the velocity, we all know that the velocity is the time rate of change of the position. And we know that the position is a vector, has a magnitude and acceleration, and they both are changing. The R is a changing. Let's say this body came here. What happens here? R is different as a magnitude, and also R hat is different in a different direction. This one is going that way, this one is going that way. So R and R hat are changing over the motion of the curve. So basically, since they are both are variable, d dt of R in the R hat direction, so you have to differentiate the first, multiply by the second, and differentiate the second, multiply by the first. So this is going to be equal to dr dt in the R hat direction plus R dr hat dt. So something first. It's very hot here, right? So is there any way that we can control the AC? Or it's controlled from the outside? So I did this last time, so if you guys didn't catch it, try to focus this time. If I have a curve like this, and for example, this is the center, and this is, for example, R. Right now it's R. Why we shift it from R to rho? Because usually if you have a cylindrical or a circular curve, this circle curve R doesn't change. But if you have a random curve, R's keep it changing, so that's why we call it rho, and it's changing with as X and Y are changing. So let's say that you have R, and the thing is, this is moving, for example, that way, from this point to this point. And this is what is gonna happen, this is d theta. So, can you guys tell me where's the R and theta direction? The body start here and end here. R is always in the direction of the radius, something like this. And theta is always in the direction of increasing theta. So the body has it moving that way, so it's gonna be in the increasing theta perpendicular to R. So this is R and this is theta. So at d theta, like let's say we're gonna look at just the infinitesimal change in the direction. So this R is gonna be somewhere a little bit like this, and theta is gonna be something like this. So this is R hat dash and theta hat dash. So if we magnify this and put them on top of each other, so you're gonna have, for example, and I'm gonna rotate them a little bit. So this is gonna be something like that, and these are perpendicular to each other, so you are gonna have R hat, theta hat, and if you plot this on top of this one, so you are gonna have this as R hat dash and theta hat dash. So this is what happened.
Why do you call them,
Because
a dash?
that's because the thing is, after d theta, they are changing. Like they are not the same. They are unit distance. Okay, so if you take the magnitude of this, it's gonna be 1, and the magnitude of this is gonna be 1. They are always gonna be unit distance, but they have different direction. So basically, here is the direction of R and theta. Once you come here, it's gonna be like this, that. So they keep it changing in the direction. Right now, I'm trying to look at infinitesimal change, like very, very small change. What is gonna happen? So basically, this is the change. Like this one came from here and became here. That is the change. And this one came from here and became here. That is the change. I proved last time how we can give this a change. Basically, this a change, like here from here, this is perpendicular to this one, and this also perpendicular. So the direction of the change is in the theta hat direction. And same thing with this one. Like this one is also perpendicular to this one, like this, and it's in the opposite direction. We tried to find the value of this. Last time I said that this is d theta. And if I want to find the absolute value of this, so this is R hat magnitude, and since this is like a piece of circle, something like this, and if you have this is R and this is theta, so the S is equal to R multiplied by theta. Same thing, if you want to find this piece as a magnitude, which is the change, this change is called dr hat. Since this is R hat and this is R hat dash, the change in R is the absolute definition of the differentiation. So dr hat.
Is it finding the resultant in statics, for example?
Yeah, you mean this one, this piece? Well, yeah, I want to find the resultant and the magnitude.
Okay.
Sorry, the resultant, which is a magnitude and direction. So I know the magnitude is equal to this part, like it's a piece of curve, which is this multiplied by theta, the magnitude of R d theta. So that is as a magnitude, we didn't put the direction yet. So this distance is this, as a magnitude. In which direction it is? It is in this direction, which I know this is 90 degree, and this is 90 degree, which makes it that this in the same direction of the theta hat. So this is in the theta hat direction. And the magnitude of R, since it is a unit vector, the magnitude of any unit vector is 1, right? So this is basically is equal to d theta, theta hat. And if I divided all of them by t, so basically dr hat dt is equal to theta dot in the direction of the theta hat. Same thing if I want to get this piece is going to be equal this, which is what I want to find out right now. This is d theta because I'm looking at the change of the theta. So d theta is gonna be equal to this multiplied by d theta, and this is equal to the magnitude of theta hat multiplied by d theta. This is as a magnitude, but I'm looking also in the direction. This is going up, and I know this is perpendicular to this, and this is perpendicular to this. R hat is going that way, and this is going that way. So this is in the negative direction of the R hat, because from theta to theta hat dash, I have to go that way. And basically, since this is a unit vector, so this is gonna be 1, and I can divide by dt for both of them. So d theta hat, because what I'm looking at is the rate of change of d theta hat. Here I was looking at the rate of change of dr hat, is equal to d theta dt, which is theta dot multiplied by r hat.
And what do you use, d theta instead of
Just one
dr?
second. Oh yeah, here, sorry. Here, this was dr.
Right.
No, just one second. This is r. This is d theta.
And the other one is dr.
And remember, because here this is still, if this is d theta, this is also d theta.
Okay, so
Right? So they both are d theta. Okay? So this are what you are gonna end up with, and all of them, so this is basically negative theta dot r hat. Anyway, so this is just a proof. I'm not gonna ask you how to develop it, but you can just expand it at home and try to play with the math a little bit to understand it. So all what I wanna get from that, I wanna find the value of dr hat dt, which I just got here. Dr hat dt is equal to theta dot in the direction of theta hat. So basically, dr dt is r dot, and it's in the direction of the r hat. And here, I have r already, and dr dt is equal to theta dot, and all this in the theta hat direction. So basically, this is the magnitude of the velocity in the radial direction, and this is in the radius direction, and this is the magnitude of the velocity in the theta direction. Okay? So this is our first. V is equal to r dot in the r hat direction plus r theta dot in the theta hat direction. That is our first important rule. How can we get acceleration? We know that acceleration is the time rate of a change of the velocity. So all what you have to do is to differentiate this with respect to the time, which is gonna be huge. dv dt. Everything in this equation is variable. R dot, R hat, R, theta dot, theta hat, all of them is variable. So if you have two variables multiplied by each other and want to differentiate them, what you do, the derivative of the first multiplied by the second, and the derivative of the second multiplied by first. How about three variables? The derivative of the first multiplied by the other two, and the derivative of the second multiplied by these, and the derivative of the third multiplied by these two. So you have to take them one by one. I'm gonna put it here. If you wanna take the derivative of d, let's say dt of x, y, and z. So it's gonna be dx dt multiplied by y and z plus x dy dt multiplied by z plus x, y, dz dt. You take them one by one. Okay, let's do the same thing here. I have to differentiate r dot with respect to the time. So this is gonna be dr dot dt multiplied by r hat plus the derivative of this. So I'm gonna put r dot dr hat dt. Right now, I'm done with this part. Let's go to the second term. Plus dr dt multiplied by theta dot theta hat plus r d theta dot dt multiplied by theta hat plus r theta dot d theta hat dt, right? I differentiated them one by one, and I put all the terms, and it's gonna give me 5 terms, right? This is gonna give me 2, and this is gonna give me 3. So I have 1, 2, and this is 3, 4, and 5. Okay, let's put this. dr dot dt is gonna be r double dot, right? So when you differentiate one with respect to the time, you have dot, another one is gonna give you double dot. and this in the r hat direction, plus r dot multiplied by dr hat dt. Let's look, dr hat dt is equal to theta dot in the theta hat direction. So we just proved this. So this is gonna be multiplied by theta dot, and all this is in the theta hat direction. So I just put this here. So let's get this one. dr dt is gonna give you r dot. And I already have theta dot here, and this is in the theta hat direction. Plus, and that was this one. Let's get this one. So this is gonna be r, d theta dot dt is gonna give you theta double dot, and all this in the theta hat, plus the last term, r theta dot. Let's see what is d theta hat dt is equal to. D theta hat dt is equal to theta dot, and it's a negative, and we have r hat direction. So I have to convert this to negative, because this is gonna be r theta dot multiplied by this, and I have another theta dot, so this is gonna be squared, and all this is gonna be in the theta hat direction, right?
And the R hat direction.
The r hat direction, oh, this, oh, sorry, this is in the r hat direction, right? Thank you. Because here, this is theta dot in the r hat direction. All right, let's arrange this. To arrange any vector, you have to look at the r vector and theta vector. The terms that has r vector is this and this. So this is gonna be equal to r double dot minus r theta dot square, and all this is in the r hat direction. Let's see what is in the theta hat direction. I have this, and I have two of these. So this is gonna be equal to plus r theta double dot plus 2r dot theta dot, and all this is in the theta hat direction. So right now I proved the acceleration equation. Here I can put it. A is equal to r double dot minus r theta dot square multiplied by r hat plus r theta double dot plus 2 r dot theta dot, and all this is in the theta hat direction. This is the second important equation. These two equations are in the equation sheet, but you know what every component means. Like here, if you come here, you're gonna find what is A and what is B. All what you need to know, this is the first derivative, time derivative of r, and this is the second derivative, and this is the second derivative of theta, and this is the first derivative of theta, so you have to know what are you dealing with. So let's solve a problem and see how the problems look like. Before I solve a problem, let's see how you guys are good in differentiating trigonometric functions. Okay, usually in these problems, I would give you theta function in cosine theta or something. And to solve for the velocity and acceleration, you have to get theta dot and you have to get theta double dot. So let's say that you have theta is equal to 3 cosine 2r. By the way, r and theta are variable. Like r and theta keep changing on the track. So, and I want you to get theta dot. Can you guys help me to get this? How can we get theta dot of this function? Which means that this is d theta dt. Before I do this, let's differentiate theta with respect to r. What is it gonna be? dr, not dt. Can you differentiate this function? It's gonna be 3 is constant, right? Multiplied by, what is the derivative of the cosine? Is it sine or negative sine? Negative sine. So I'm gonna have this is equal to negative sine 2r, that's it? Or there's something else?
Times 2.
Multiplied by 2. What is 2? The derivative of what is inside the sign. Okay? So that is gonna be that way. Let's differentiate the same function with respect to the time, not to the r. So this is gonna be the same thing. 3 times negative sine 2r, but here the thing is the derivative of 2r, like ddt of 2r is not only 2, it is 2r dot dr dt. Okay, because if you differentiate this with respect to r, is going to give you 1. But if you differentiate this with respect to the time, so this is going to stay dr dt. There's nothing that you can do about it. All what you are going to do is you are going to take 2 outside, and this is dr dt. Because the thing is, this is not dr with respect to r. This is dr with respect to t. There you cannot say it's 1. So this is going to be end up with dr dot. Do you guys understand that? Okay? This is the same thing when we're differentiating like function x squared, and if we want to differentiate this with respect to dx, so this is going to be 2x, and that's it. But if we want to differentiate this with respect to t, so this is going to be equal to t2, and once you are differentiating it, it's going to be 2x dx dt. So you are going to having this 2x multiplied by x dot. Okay? This is the same thing. 2x multiplied by dx dx. But the thing is, dx with respect to dx is equal to 1. Alright? So this is what you should be careful about, because from previous years, most of the students, they made mistakes in the differentiation. They don't know how, they know how to differentiate, but they always forget that they are differentiating with respect to a different variable from the variable in the equation. So at the end, they have to put here, like this is negative sine 2r, they have to put 2 dr dt at the end. Because you are differentiating a function that is in r with respect to t, so at the end you have to put dr dt. If you are differentiating with respect to r, there's always dr with respect to dr. But we always remove it because it's r, it's usually equal to 1. So be careful. Okay, so let's get back to this. So this is going to be equal to 3 negative sine 2r, and we have here 2 dr dt is equal to r dot. Alright, this is easy. What is next is a little bit difficult. What if we try to find theta double dot? Let's make this negative 6 r dot sine 2r. How we're going to do it? There is 2 components, so I have to differentiate the first, multiply by the second, and then the derivative of the second multiplied by the first. Can you guys tell me what is the derivative of the first term?
R double dot.
It's going to be
R double dot.
negative 6r double dot, the derivative of this, dr dt, so you're gonna, and this is multiplied directly by sine 2r, that's it. I finished the first term. Second term is gonna be this as is, so it's gonna be negative 6r dot, multiplied by the derivative of this with respect to the time. So if you differentiate sine, it's gonna give you cosine 2r, that's it, or there's something here. So here is going to be 2, the derivative of this 2 multiplied by dr dt. Because I'm not differentiating with respect to r, I'm differentiating with respect to the time. If I'm differentiating this with respect to r, so just going to be 2 multiplied by dr, which is going to be 1. And since I'm differentiating this with respect to the time, so this is going to stay the way it is. So if I want to write this, it's going to be negative 6 r dot sine 2r plus, I'm gonna have this is r dot, and I have 6r dot here, so this is gonna give me negative 12r dot squared cosine 2r. Alright? This is the most difficult part with the polar coordinate system, is to get the derivatives right. Once you got them right, everything's given. R is given, theta is given, you just plug r and theta and r dot in the equation, and you are done.
So for things like the acceleration formula, we could just use the formula
No, this is just I'm showing you where it's come from, but most of the problems, it's just a direct application in the formula.
And then for that sample over there, what would be, let's say, the work? The
Well,
working
we are
on-
gonna solve that full problem next time because we don't have that much time, but I just showed you how it's working. I will give you a theta, function cosine r, or I give you r, function of cosine theta, and you have to differentiate them, and then substitute in the equation, and at the end, once you have theta dot, and you have theta double dot, you can substitute in the acceleration equation. Because here, in the acceleration equation, all the variables are r dot, r double dot, theta, so you have to find r dot, r double dot, theta dot, theta double dot. Once you find all of these, you can find the velocity and the acceleration.
So like basically the work.
Oh, yeah, that would be 24 hours.
Yeah, this is most of the work. Alright, the quiz is online right now on campus. I saw some of you already submitted the quiz right a few minutes after I put it online midnight yesterday. So try, they only have one attempt. So try like to have a good internet so it doesn't like crash while you're doing it. Just 30 minutes, and it's a very, very simple problem. It's very easy on the first part that we had. And I'm gonna assign the second homework today, so watch out. I put it? Quiz?
Oh, it is due today.
Yeah, he ran.
So it was open yesterday.
It opened
Yeah, it opened at midnight. So it's like.
Oh, really? Tristan's waiting for us to work. Go the other way.
Have you done the quizzes?
Did you know that was right?
Like for example, one of my classes last semester, evaluating engineering.
No worries, no worries. If it's, if it didn't, there's an issue with the grade.
So I think yes, because he said he asked if they were going
The
to.
midterm?
I'm gonna take it.
Well, I don't know yet, like, we are,
Is it based off how much content?
I think we are gonna cover in the exam chapter 12, all of it, and part of chapter 13. Yeah, so kind of, like maybe after, we still have, you said how many weeks? Oh, let me stop you.
You said it was like 5 weeks into the, at least on the syllabus, it says 5